Hi everyone. So what I have here is the NodeMCU. This is actually the version 3 board, and actually a NodeMCU is just a breakout board for an ESP8266 microcontroller. Okay, so this is the ESP8266. So what's special about this device is that it can readily connect to your Wi-Fi, and with that you can add internet capabilities to your project. One thing that your ordinary Arduino Uno cannot do. So this is using the ESP12E device right here. This is actually a newer ESP board compared to the older one, which is the ESP01. So this is the ESP01. Basically, they are the same device. They are both ESP8266, but this one has a different layout for its board. Anyway, this is the ESP8266 right here. This one right here. Okay, and you can see in this board you have your headers, and there are a lot of users commenting that this is actually hard to use, especially if you're using breadboards, because you cannot just mount this on the breadboards. Okay, although there are available adapters, but again, this is not really breadboard friendly. And also, another thing you could notice is that there is no USB port here, so you cannot actually connect this directly to your computer. Compared with the Node MCU, okay, it has a micro USB port here, so you disconnect your cable, and then you can program the device using your computer. Okay, so basically, this is a microcontroller. The ESP8266 is a microcontroller which you can program, and with added Wi-Fi or internet connectivity capabilities. Actually, this is not um, the best Wi-Fi device to use for now. For example, I would recommend the ESP32, but it's a good starting point for those who are venturing or are new to Arduino programming and then want to add Wi-Fi capabilities to their Arduino projects. So here, I will show you how you can configure or use this board using the Arduino Ide. So basically, you will be programming this board with the same programming language that you use to program your Arduino. Okay. So what other things about this board? You have your pins, of course, right here, GPIO pins. Okay. So maybe I can discuss this in more detail later on. So you have your buttons. You have your reset button here, reset button, and then you have your flash button. So you actually press this one if you want to change the flash program on your ESP8266 device. And you have your regulator here because your ESP8266 actually runs on 3.3 volts and your micro USB port runs on 5 volts. So you cannot, of course, obviously you cannot run this directly to 5 volts because that would destroy the device. And then that's about it. Okay, that's about it. So for the next part, let me just show you how to set up this device and to start programming using the Arduino language. Okay, so there are actually two versions, at least the two current versions for the Node MCU. And luckily I have two here so we can compare. So this one right here, this is the version 2. And this one, this is the version 3. So as you can see, version 2 is smaller. And of course, version 3 is, the V3 is larger. But that's not the only difference. The other difference is that they actually use different drivers. So in order for you to use this or use any of these boards to your computer with your computer, you need to install the drivers first, provided that they are not installed yet on your computer. So for the version 2, this actually uses the C Labs 2102 driver. So you can download the driver for this board here, this website. So let me just share this link to you. So depending on your operating system, you can just download. This is just a very small file. So click here, then download, then that will download, or then you install, of course, then that will install your driver for this board. Okay. For the version 3, the driver for this one is the CH340. So you should go to this website right here. Okay. And again, I'll be sharing this link. Then you just click this. Then, of course, after downloading, you install that. Now, to check if you have your drivers installed correctly, you can use Device Manager in Windows. So for example, if I connect this to my computer using a micro USB cable,
Hello.
okay, so you can go to Device Manager. Okay, Device Manager. Then go to ports, and you have your port here. So it says that it's on COM3. So this actually confirms that we have installed the correct driver for this board. Okay. Of course, if I remove this,
Goodbye.
and that would remove whatever is on the device manager. Similarly, for this one, if I connect this one,
Hello.
okay, and also it shows that it's COM9. Okay. So this is a different port assignment, COM9, obviously. Okay, so that tells you that you have installed the correct driver for either of these boards.
Goodbye.
Okay, once you have the correct driver, the next thing we do is to add support for these boards to the Arduino Ide. Okay, so you need, of course, to install the Arduino Ide for this one. So open Arduino Ide. Okay, go to File, Preferences, then look for the additional boards manager URLs. Okay, so if you have multiple, if you have already done this, then maybe you have an idea how this works. So just click it, click here. Then these are all the JSON links that you need to add the board definitions for each supported Arduino board. So for the NodeMCU, any board version, you need the ESP8266 core. So this is right here. This is the one. Okay. I'll be also sharing this link. Add that one. Then click OK. And then click another OK to close the preferences window. Then after that, you go to Tools, Board, then Boards Manager. Okay. Then you search for the ESP8266 board package. So you just use the ESP8266 keyword. Okay. Then search. Oops, it's not appearing. So let me just do that again. Go to Tools. Maybe my ID is updating. I don't know. Okay, go to Tools, Board Manager. Okay, then again, we do that again. It's downloading. So let me search for ESP8266. Ayan. So it's here. Then for me, it's already been installed. So my install button is disabled. So for you, if this is your first time, this would be clickable. So you just click this one, and that would install all the board definitions for all the supported ESP8266 board, including these two NodeMCU boards right here. After that, you just close. Then to check if you have the board definition installed, go to Tools. Okay, Tools, then Board. Then look for the list for all the ESP8266 boards. Okay, so this is right here, and you have this board right here. So for these two boards, you can actually select NodeMCU 1.0. So this works for both the version 3 and the version 2 boards. So just click NodeMCU 1.0 right here, and that would add support for this board. Of course, you need to specify the correct COM ports. So let me just, okay, so I'll just connect my micro USB cable to my version 2 board.
Hello.
Okay, it's my version 2 board. Then I go to tools, then port. So it's COM3, so it's correct. Okay. So I have here an example code. This is actually just a blink code. Okay. So you see here, you have onboard light emitting diode. This is actually GPIO2, or general purpose input output pin number 2. Okay, so that's for GPIO. Um, so here I have my code for my setup. I have my pin mode 2 output, basically, because this would be an output pin because you have a blinking LED. And then I have here a blink program, very basic. Okay, so here I turn the LED on, wait for a second, turn the LED off, then wait another second, this goes to a loop, and then you have your LED blinking. So if you upload this one, okay, so wait for the percentage to reach 100, and that would tell you that it's done uploading. Right, and you will see your blue LED flashing right here. So that's done, and no need to reset the board, so it's now blinking. Okay, and the same code works for version 3. So let me try version 3 board.
Goodbye.
So we'll connect version 3, and just
Hello.
to see any difference, I will adjust the rate of the blinking to a half a second, so that will be 500 milliseconds. Okay, then of course need to specify the correct port. It's COM9 for this board. Then upload. Same way, we wait for the percentage to reach 100, which tells us that it's done uploading the code to the board. Okay, the same, it's still flashing. Same way with version 2. Okay, that's it. So as you can notice, this blinks faster than the one in the version 2 board because, of course, their code is different. So that's about it for our initial setup with the board. Okay, I hope you got that. So for the links, I'll just be providing the links. Okay. Uh, Maybe next part would be how to set up a basic web server using the NodeMCU board. Okay, so I have an example code here that shows the Wi-Fi capabilities of the NodeMCU and the ESP8266. So basically, this creates a web server. When that web server can, with the web server, you can control the onboard LED, the one that we made uh, blinking earlier. So the code is here, okay, the screen. So what we need are these three libraries, okay. So these libraries are already included once you downloaded the board definitions like we did earlier. And then here I declared my SD ID and password. So again, you're welcome to connect to my Wi-Fi if you can reach our home, provided that I will change change it, of course. Then start to create the server. We create a class using the ESP8266 web server class. Then you name it server. Of course, you can change this whatever you like. But here, it will be easier to just name it server. Then you provide the port. So since we're using ACTP, we will be using 80. Okay, and then I declared an empty string page. This is actually where we will write our HTML code for our web server page. Of course, our web server will have a web page. Okay, so this is just the string to contain that page. Then for here, I will let me just change this to 2, of course, because we'll be using the onboard LED. Okay, that would be pin 2. Then this is the web page. This is the HTML for the web page. So this is just a simple H1 header and the title of the server, simple NodeMCU web server right here. And then I have a link. I hope you're familiar with HTML code. It might be better if you can look at it in its output form. So basically, this is an HTML containing two buttons, one LED on, one LED off. So if you click LED on, the LED will turn on. This onboard LED will turn on. And if you click LED off, then this button will turn off. Okay. So similarly, we initiate the LED pin as an output. Then we turn off that pin so that when the board boots up, the pin is turned off. Then we had a second delay. Then this one is for debugging. So if you're familiar with Arduino Ide, you can use this to create debug log or some sort of feedback from your code so that you can know if something is going wrong. So here I set up it at 115.200. Then I begin the Wi-Fi connection using my provided SSID and password. And then this part right here. This is just to check if your Wi-Fi is still connecting. So if it's still connecting, then you will see a series of dots on the serial monitor, which I will show you later on. Then some more debugs or output to the console. This actually prints the IP. We need the IP. As soon as this connects to the Wi-Fi network, it will be provided an IP by your router, and we will be using that IP to connect to our server. So this part right here prints that IP. Then we start the server. So to start the server, we use server.on. Then the parameters would be the page. So if it's home page, you just write slash. Then whatever you want to return to the client when the client goes to that page. In this case, it's the home page. So it will return 200. That's the HTTP status code for OK. Then the type of data that you are presenting. Then the page. Recall that page here is this string right here. Okay. So this is when the user clicks or goes to the home page. And then if the user clicks the button, okay, so if we go back to the HTML page, if the user clicks the button, it will be redirected to the LED on page, which is what is happening here. So if the user clicks on the LED on button, so it goes to the LED on page, and then on that page, it will show the same page, okay, the same home page, but then along with it, it will turn on the LED pin with this command. Okay, and then some delays, second. Similarly, if the user clicks the off button, it will be redirected. He will be redirected to the LED off page, and that LED off page will still serve the same page HTML, but in this part of the code, the LED pin will be turned off. Then another delay of a second. Then you begin the server, and then you just write something on the serial monitor saying web server started. And inside loop, you have your server under client. So this should be inside loop so that your web server can continuously detect any user on the server. Okay, so I will upload this code. Okay, so I will upload this one. Wait for the upload to finish. I will be providing a link to this code. Okay, so again, we wait for this one to reach 100, or just wait for done uploading to be written here. Okay, so code is uploaded. Okay, so we need to open serial monitor. So you can click it on the upper right, or you can also go to tools serial monitor, or you can press Control Shift M on your keyboard. So, okay, so this opens the serial monitor. And make sure that this number here, this baud rate, matches your baud rate in your code. So in my code, it's 115,200, right? So that should be the same here, 115,200. Okay, so let me just reset the board. So you have a reset button right here. This is the reset button. So just press that. Okay. So, oh yeah. So it says that it's connected to my Wi-Fi, and this is the IP address. Now this is the web server address. So I will be using the browser. I'll be needing this IP address. So let me just open the browser. Go to incognito, and then type that IP address, and this is my web page. So this is what the string page HTML is. So this is its output, right? So if I click off, since my LED is currently on, so if I click off, okay, it's not working. So let me just start again. So click off, please click on. Okay, so it's the opposite. Yeah, something's might be wrong with my code. Okay, so if I click off, it turns on. If I click on, it turns off. It's opposite actually. So let me just revisit our code here to see where we got it wrong. So it's led off, it's low. Okay. Okay. I think I got the reason. I think it's the way this LED is wired to this board. It's actually wired as if you uh, put a high state on the pin, this LED actually turns off. If you make it a low state, it actually turns on. Okay, so if we can just reverse that on our code, so let me just write this as low, this one as high. We upload again. Okay, I think this should work now. So actually, it takes time. Uh, this is actually slower compared to the newer ESP board, which is the ESP32. Actually, very useful still. If you want speed, if you want more memory, then you would upgrade to the SP32. But that would be a little bit more expensive compared to this one. So I think that's done. We go back to our server. Okay, let's refresh this one. Okay, so if I press off, okay, it's turned off. If I press on, it's turned on. So that's about it for our first example. It's the simple web server when we are controlling the onboard LED on this board.